In this group of problems, we're supposed to evaluate expressions that look like this. We're given a logarithmic expression. Let's find its value. Now, in 59, we've got the log base 2 of 16. Well, what is a logarithm? Just keep in mind, logarithms are exponents. And I'll put it right back up here so we remember it. So logarithms are exponents. So what are we looking at here? We're looking at an exponent. Now, exponents go on bases. What's the base here? The base is 2. So you have to think about this. 2 to what power would be 16? All right, now these should be guessable. So what we're going to say here is that should be a 4, right? That should be a 4. So what we're claiming is that the log base 2 of 16, that's 4. Now this one's going to require a little bit of thought on our part, more than 59. What we're trying to do is determine what value this is. So I know it's an exponent. So what exponent am I going to put on 25 to get to 125? So I'm thinking this. 25 to what power is 125? This one does not come to me right away because what I do know is this, right? I think we know these, right? 25 to the first, that's 25. 25 squared, that's 625. Well, to the first power is too small, below 125. To the second power is way too big, so it's way above 125. So this exponent has to be somewhere between 1 and 2. So I've got to be thinking this, 25 to some fraction is 125. See if I can erase that, 125. Now, denominators, those are the roots. All right, what are you going to put down there for the root? Well, what roots of 25 do you know? We don't know too many. Matter of fact, I think we know only one, right? That's the square root. So I think that's going to have to be a square down here. So if I take the square root of 25, right, if I take the square root of 25, I'm looking at 5. Now, 5 to what power? That's going to be the numerator. 5 to what power is going to get you to 125? 5 squared is 25. 5 to the third, that's it. So this is going to be a 3 right here. So that numerator has to be a 3. So what we're saying then is that the log base 25 of 125 is 3/2. Now, we're looking at an exponent here, right? We're looking at an exponent. What exponent are you going to put on 3 to get to 3? So 3 to what power is going to give you 3? Well, that clearly has to be a 1, right? So that's going to be a 1. So we're saying that the log base 3 of 3 is 1. In fact, how about a more general statement here? Because things like this come up a lot. What if you have the logarithm base b of b? So what happens here is that the base and this base match. They're identical. This is always going to be a 1. So in our case, we have 3 and 3. It's going to be a 1. If it was 15 and 15, it would be a 1. I'm going to do these two together. 67 and 69. Look what we've got. The logarithm of 1. The logarithm of 1. They just have different bases. Let's do this by first looking at 67. The log base 5 of 1. Now, the logarithm is the exponent. So we've got to think, what exponent would we put on 5 to get back to 1? So 5 to what power takes us back to 1? Well, we know this. If that's a 1, then we would get 5, right? 5 to the 1 is 5. This is smaller than 5. So this has to be smaller than 1. Now, do you remember this rule right here? Back from a long time ago in algebra, that if you had this, if x to the 0, that's equal to 1, as long as x is not equal to 0. Remember that old rule? So what we're going to have here is a 0. So this one right here, the logarithm base 5 of 1 is 0. So I'll write it here. If I can, the log base 5 of 1 is 0. And that's going to be the same thing that happens over here. What exponent would you put on 17 to get you to 1? It says 0. So the log base 17 of 1 is 0. In fact, let's make a general statement here. Let's say this. If you have the log of any base of 1, that is 0. So we've made two general statements now. This one here, the log, and if the bases match, you get a 1. But if the log of any base at all of 1, the log of 1 is always 0, no matter what base you put in here. Any legitimate base, you take the log of 1, you get a 0. 73, we're looking at the logarithm base 100 of 1,000. Now logarithms are exponents. Exponents go on bases. So what exponent are you going to put on this base of 100 to get you to 1,000? Well, we know this. This is similar to that number 63 we did a while ago. We know that, let me get rid of that. We know that what? 100 to the 1 is equal to 100. Then we know 100 squared, that's 10,000. So the 1 is too small. The 2 is too big. So this has got to be somewhere in between, right? 100 to some fraction. That's going to give us the 1,000. Now this is a fractional exponent, so the denominator is the root. What roots of 100 do you know? I know only one, and that's going to be a square root. That'll get me to a 10. So if I put a 2 down here, I'm looking at what? The square root of 100, which is 10. Now 10 to what power? That's the numerator. 10 to what power brings me up to 1,000? 10 times 10 times 10. That's 1,000. So that's going to be a 3. If I can write it. So that's what we're looking for. That fraction I'm looking for is 3/2. So we'll make this statement here now, that the log base 100 of 1,000 turns out to be 3/2.